striatal ganglia that is associated with motor and cognitive function. So this is just a bit of background. We aim to explore the effects on virtual reality in a rodent model of Parkinson's, which then we can draw conclusions to benefits that this may have in humans. So my hypothesis for this research objective is that VR-inspired enrichment will improve neuroplasticity and motor function in Parkinson's disease. And we're going to be looking at rodent models for this, as this will offer insights into developing effective VR rehabilitation strategies for humans. So this is just how this research extends on previous research. So first, um, the use of environmental enrichment in rodent models is not particularly new and has been done before, but the specific application of VR in this and specifically tailored for Parkinson's is a new approach, and it bridges a gap between the traditional environmental enrichment methods and VR. And next, this whole research is specifically focused on the Parkinson's disease, and this disease targets motor dysfunction and deficiency, as well as degrading neuroplasticity. So the methods and the study design for our methods was model creation. So first, we wanted to utilize and use the 6-OHDA lesioned rat model to simulate these. And this specific rat model is a Parkinson's disease animal model that has been used before. And we also plan to use groups. So we call the first group virtual reality inspired environmental enrichment, which is the group that we're going to be testing virtual reality in. The next is their standard environmental enrichment, which is the standard environmental enrichment models that has been done before. And then lastly is our control group, which will have no enrichment or any changes done to it. So the duration for this research, I planned it to be 8 to 12 weeks because um, when I found in research, it showed that Parkinson's timeline usually have the neuroplastic changes happen between 8 to 12 weeks. So I thought it would be the same. So to collect data, the first method we plan to use is behavioral assessments, and this will help us test for motor skill improvements that are Parkinson's disease specific. And the second that I plan to use to collect data is neuroimaging and histology. One of the forms that we can do is MRI scans. So MRI scans are basic scans that detect and observe brain structure changes and neuroplasticity markers, which will enable us to test and prove the hypothesis. So in our statistical analysis, I used ANOVA, which is uh analysis method that compares improvements and significant changes within the groups. And then I also plan to use correlation analysis, which can link engagement levels in the VR environmental enrichment group. So this image is just for purpose of discussion, and it's an image to explain the VR setups for rodents. So in the A, you can see that that's the general components of a rodent's VR setup, and it includes a device to restrain and track animal movement and equipment to provide the sensory stimulation. So here there's a system where there's a spherical treadmill, a fixation permitting free rotation of the animal around its vertical body axis, and a projection of a visual VR onto a projection screen. So in my research, I found that projection screens work better for rodents, as rodents, their field of view can extend to 300 degrees. And then B to F, you can see there's different types of restraints that are used in the rodents VR systems. So this is a summary, and this study aims to demonstrate the potential of VR-inspired environmental enrichment in accelerating neuroplasticity and motor recovery. So we plan to provide foundational insights for translating these benefits to human rehabilitation protocols for Parkinson's disease patients. So here are the results that I expect based on our hypothesis. Firstly, we expect there will be enhanced motor function, neuroplasticity, in the virtual reality environment enrichment group compared to the standard enrichment in the regular control group. We also expect that VR tasks will significantly contribute to neuroplastic and motor recovery improvements. And lastly, we can see the correlation between engagement in all groups. These will tell us a degree of improvement in motor and neuroplasticity markers. So here are some limitations and future directions. So limitations, the direct translation of rodent models outcomes to human conditions may be limited by differences such as the disease manifestation and the treatment response. Also, the complexity of simulating human VR environments for rodents, it won't fully capture the human VR experience. So future research could focus on refining the VR rehabilitation tasks based on the insights gained, and this can explore the applicability of findings in these clinical trials. The future studies may also investigate the integration of VR with other therapeutic approaches, such as pharmacological treatments to enhance overall rehabilitation outcomes. And these are my references, and thank you for listening.
Great. Thank you so much, Sai Karthik, for the wonderful presentation. I just want to see if the judges have any question for Sai Karthik.